B.4, find both minimum and maximum. In this part, we will solve a special problem that is related to some special cases of the selection problem. Find the minimum, it's a special selection problem. Find the maximum, another special selection problem. But here, we changed a little bit. Find both the minimum and the maximum simultaneously. Here, notice that simultaneously. Yeah. All right, let me write the problem first. The problem. All right, let me just write the main part. Find both the minimum and maximum simultaneously of an array. All right, yeah, that's the problem. So this is important. I emphasize this simultaneously. Yeah. Otherwise, not very interesting. Okay, all right. Here, when we find a solution, we want to find the best solution. The best solution. All right. Let us look at the solution. The first try, when we do first try, we do not need to get the best solution. The first try, we just want to find a solution. Okay? We just want to get something first. Our initial version. All right. Yeah. So let us look at this method now. Assume that we have n elements. N element array. All right, n element array. Yeah. Step 1, find its minimum. How many comparisons do we need? Yeah, we're familiar with this question. Finding the minimum, we need n minus 1 comparisons, right? All right. Step 2. All right. Then find its maximum. Yeah. But this time, when you find the maximum, can you remove the minimum? Yeah, because minimum cannot be the maximum, right? Yeah, here we can consider a greater than 2. Then you need to do some meaningful work, right? Yeah. Otherwise, too trivial, right? Yeah. So first we can take away the minimum. All right. After you take away the minimum, now not only, yeah, n minus 1 elements left. All right, yeah. Then next, find its maximum. How many comparisons do you need? Yeah, so here, need n minus 2. Yeah, not 1, because you have total n minus 1 elements. One fewer than that need this many comparisons. All right, okay, yeah. Total, yeah, because we did 2 steps. So the total, the first step n minus 1 plus second step n minus 2, 2n minus 3. Yeah. All right, so this is the first try solution. Yeah. Here I like to tell you, so this solution is not good. Yeah. It is not a good solution. Why not a good solution? The reason is very simple. The reason is very simple, not a good solution. Because, look at here. In the first step, you use n minus 1 comparisons to find the minimum. All right? You spend a lot of comparisons. You're supposed to get a lot of information, right? You should collect a lot of useful information in the first step. But that part of information, you do not use it. When you go to step 2, you throw away the information from the first step and you just work on the second part, finding the maximum without using any useful information from the first step. That means you waste a lot of comparisons. So that's the problem. All right. So in order to use all the useful informations to find a final solution, so we should arrange our data in a good way so that we can use all the useful information to get a solution. Yeah. All right. So next, we want to get a good solution. Yeah. So this time, yeah, we want to work on a good solution. All right. But for the good solution, here, I want to consider a special case. All right, so I want to consider n is an even number case. Yeah. For odd number case, I leave it to you. All right? Yeah. You just modify the solution for the even number case slightly, modify a little bit. Yeah. You still, the whole arrangement pretty close. Yeah. So then, after that, you can get a odd case solution. So I leave it to you. Yeah. So you need to do some work. All right. So here I assume we have even number of elements. So here I use x1, x2, x3, and so on. X and the last 2 elements, 2n minus 1, 2n. All right. Now I do a special arrangement. It is important, this arrangement. All right. Yeah. I arrange all these elements in pairs. Okay, in pairs. All right. Yeah. The first pair, x1 and x2. Okay. Second pair, x3, x4. All right. You can see the pattern. Yeah, we just use this pattern. Yeah. All right. Yeah. The last one, 2n minus 1, x2n. How about that? This kind of arrangement. Arrange all the elements in pairs. Yeah. Then each pair we do one comparison, right? Yeah. One comparison. Each one comparison. Each one comparison. That means we need to do n comparisons to get the smaller elements and the larger elements. All right? Yeah. For simplicity, let us assume above this line, smaller elements above this line. We just assume for convenience. All right? Below this line, larger elements. How about that? Yeah. All right? We just make that kind of assumption. Yeah. Now think about that. Basically, we get two groups of elements. Two groups. Yeah. The upper group and a lower group. Okay? All right. The question is, the upper group contains the minimum. Right? Yeah. The lower group contains the maximum. How about that? This observation is critical. This observation is critical. All right? Yeah. That means in the upper group, we do not need to look for the maximum, right? We do not need to do redundant work trying to get the maximum in the upper group. In the bottom group, we do not need to look for the minimum. No need to do it. Yeah. So the last step, we get our solution. Yeah. Now we are pretty close. All right. So the last step to get a minimum, all right. So let us list all the elements in the upper group. N elements, right? Total number, n elements. To get a minimum, n elements, we need n minus 1 comparisons. Yeah. Then, the bottom group, x2, x4, last one, x2n. In this group, we need to find the maximum. We needed n minus 1 comparisons. How about that? All right. Finally, we put all these steps together. We find a solution already. We just need to count the total number of comparisons we need. Yeah. First step, n comparisons, right? Then n minus 1, another n minus 1, total 3n minus 2. How about that? 3n minus 2, yeah. But remember, the total number of elements equals even number 2n. 2n, not n, okay? 2n. Or you can call 2k, okay? Yeah. Just an even number. Even number, yeah. But this n is not the original n, okay? Do not get, yeah, probably I should use a different symbol. Yeah. It's not original n, okay? Yeah, then you may get confused. Yeah, all right. Original, how about, yeah, in order to avoid confusion, how about I change original number to m? How about that? Then no confusion. Yeah, because after that, we know n equals m over 2. All right, so then we can write it equals 3m over 2 minus 2. How about that? And this time the total number of elements original array, that's m. 3m over 2 minus 2. All right? Yeah. So then you can see approximately 3/2 of the original problem size. Approximately, yeah. The previous bad solution, 2 times the original array size. Here, 1.5 times the original problem size. Yeah. If we just ignore the, 2 minus 2 small term, you can see the difference is pretty significant, right? Yeah. Try to understand this solution, this method here, a smart method. Yeah. Then I think you do some small modification, you can get a solution for the other case. Small adjustment. Yeah. All right, so I finish this example and the whole part D of module 4. All right, yeah.